road will take us now. It's not that you're timid, no one could say, choosing to walk with the gale. What shall we call us? Hobos per se. We'll find that out on the way. So let us just do, my love, and not stop thinking of this over. Let us just do, my love, and see where this road will take us now.
Well, good evening, everybody, and welcome to Environmental Coffee House. I had, Jennifer, when we started, we were talking about the audio in our articles tonight and how these obnoxious online things start playing. Well, as I started the video for you guys, one of the videos started playing and there was screaming, and I'm like, what is it? I had to figure it all out, but I think I fixed it. So guys, maybe you thought it was part of the music. Hello.
It was all talking to us. All these videos are like
Oh my
talking
gosh.
spontaneously in all these
Yes.
and you have to keep going in and turning the sound down. It's like, stop.
It was crazy. And I'm like, oh my gosh, everybody's gonna think it's it's part of the thing to scream like that. But how is everybody out there? Kim is here, Armand and Cindy Seeley and Jennifer. People are starting to send in their gardening pictures, and and
Good.
Karen Reese
so
and
happy.
Warren's here. Climate Marcher John. Oh my gosh, Robert Crane, Lightning Rod, Tom Hall. Raza and Scott Andrews and Rich Diana. All right. So this is good. We have a good show tonight. Hope you enjoyed that little opening, little sweet thing. And
So
hi, Hunter
beautiful.
Z. All right. So we're going to get started tonight. We have a pretty good show. Jennifer, you want to do the overview of
Yeah.
the show? Awesome. Perfect.
Absolutely.
Perfect.
So this is I think my favorite blend of topics, what we're going to be talking about tonight, and I bet it is for a lot of you too. So
Good.
we're going to be talking about tipping points and the Arctic and methane and hot blobs of water. What could be,
Blobs.
I don't know, more enticing. So we're going to start out with an article from cbsnews.com. Climate tipping points may have been reached already. Experts say, no, say it's not so. That's very scary.
Say it's not so.
Exactly. And then we're going to go straight up to the Arctic, and we have an article from eos.org.
Yep.
Massive methane reservoir is lurking beneath the sea. So that's pretty interesting, right?
Yeah.
Because I've been thinking about methane for a long time.
How many?
And
About
talking
10
about
years? Yes.
Yeah. Oh, yeah.
I would say.
Scientists have found a methane reservoir below the permafrost seabed of the Laptev Sea, a reservoir that could suddenly release large amounts of the potent greenhouse gas.
Potent.
Scary stuff.
Potent.
Scary
Potentiate.
stuff. And right. And that has a real Swedish influence. There's a couple of very brainy, smart people who were involved in this study from Stockholm University. Orhan Gustafsson and Julia Steinbach. Both of those guys are in Stockholm University.
Okay.
So they're very involved with this methane reservoir, which is fascinating, guaranteed.
Hi, Val.
Then we're on.
Sorry. I'm not used to seeing
No, it's
Val
all good.
live with us.
Then we're on to an article from CBS8.com, and this has to do with a brand new topic, which is very interesting, and lava lamps come to mind, actually.
I just saw a bunch of them the other day.
Yeah, well, just think about these heat bombs. So we're going to be talking about heat bombs, right? Heat bombs in the Arctic. Scripps Institution of Oceanography researchers discover heat bombs destroying Arctic sea ice.
Heat bombs,
this is
baby.
So fascinating.
Yes,
so fascinating. Researchers recently had a breakthrough in finding the specific mechanism behind the rapid melting of the sea ice in the Arctic Ocean.
God.
So
yes, we're going to show the articles. Absolutely. So what we're going to do is I'm going to start out with the little climbing tipping points article. And I want to know, guys, if you can hear this. We'll start out with Jeff Baradelli telling us, I don't know if it's the whole article, but let's see if this plays. Of course,
the 2021
I don't know how to get rid of
Sportage
a
LX
commercial.
all-wheel drive for $159 a month.
So we have to watch the damn commercial. All right. Can you guys hear this? I want to know because the software has new.
Okay, Buggy, it's a T4 series. I have a red, a blue, and a green.
Roger that, Jack. Downloading the manual. Oh, that's a big boy file. Detailed deleted.
Meeting virtually to try and curb the planet's carbon output. Yesterday, President Biden recommitted the United States to cut our greenhouse gas emissions by 50% by the end of this decade. And China reaffirmed its pledge to be carbon neutral by 2060. Climate activists and scientists say we can still take measures to slow the warming of the planet before it's too late. But climate researchers also have evidence that we are dangerously close to a number of catastrophic tipping points. Joining us now to discuss the science is CBS News meteorologist and climate specialist Jeff Baradelli. Jeff, these tipping points, you've spoken to researchers about them. What are they? Break it down.
I have to tell you, it's concerning. Unanimously, all these scientists say that we are much closer to tipping points than we thought we were just a decade or two ago. And one of those we're very close to is the Amazon rainforest. So the Amazon rainforest has been around for 55 million years. But it's crazy to think that in just 1 century, human civilization could completely wipe it out. So far, we have deforested 20% of the Brazilian Amazon. Let me tell you why that's important. Because the Amazon rainforest is only a rainforest because it is a rain-making machine. It produces 50% of its own rain, and the way that it does that is it exhales from the leaves and the canopy. All that water vapor into the atmosphere causes a river of clouds and rainfall to fall. So it's a self-sustaining system. However, as we begin to break apart the Amazon into pieces, all those fires that you see, we reduce the ability of the leaves and the trees to create its own rain. And believe it or not, scientists say, and the foremost experts say, that we could see this lush, wet rainforest transition to a savanna in only 20 to 30 years. And Vlad, the reason why that's so important is because think about all the biodiversity in the Amazon. We'd lose a lot of that. And also, think about all the carbon that is stored there. Billions of tons would be released into the atmosphere, making climate change even worse.
Let's talk about Antarctica. We've all seen those heartbreaking images of polar bears trying to find a place to land while they're swimming through the ocean. What does the rising temperatures in Antarctica mean? What else is troubling about that?
So Antarctica is a canary in a coal mine. It has ice miles thick. And if all that ice were to melt, that would be 200 feet of sea level rise. Now, it has been stable for a very long time, and scientists thought it was stable But a few years ago, they started to notice a rapidly evolving situation in West Antarctica, specifically Thwaites Glacier and Pine Island Glacier starting to become less stable. Let's talk about why that's the case. The reason is that we have warm water. Water temperatures have been warming in the oceans by 2, 3, 4 degrees Fahrenheit. It's getting underneath these glaciers, which stick out very far over the ocean waters. That's breaking up the ice shelves like a dam. The dam is beginning to burst. And once that happens, it's like pulling a wine cork out of a wine bottle. All that ice flows from land into the ocean, raises sea levels. Those two glaciers have 4 feet of sea level rise. Not going to happen next decade or the decade after, but by the end of the century, we could see several feet of sea level rise, swamping hundreds of millions of people who live along the coast. That's a big deal.
A lot of people will say, look, this is happening on the other side of the world. I live here in New York City. What does this mean for me?
Yeah, so the problem here in the North Atlantic is we have something called the Atlantic Meridional Overturning Circulation, the Gulf Stream system. Now, the Gulf Stream, we know about it. It produces warm water, brings it up from the Gulf of Mexico. It's responsible for redistributing 20% of the heat from the warm tropics to the poles. Now, this is beginning to slow down, and it's a big deal because it is a linchpin in the climate system. Near Greenland, what we really need to run this engine is dense, cold, salty water. It sinks, runs that engine. But Greenland is beginning to melt. And as Greenland begins to melt, we're seeing that fresh water flow into the North Atlantic.
Nothing we don't
Fresh water
know.
doesn't sink as well. So the whole conveyor belt is slowing down. It slowed down 15% since 1950, could slow down by 45% by the end of the century. That could tip it, stop the current, and that would throw weather patterns in the North Atlantic from the East Coast to Europe completely off kilter, raise sea level rise. Remember, this right here is a linchpin. It controls the whole climate system. That's a big deal.
All right, so it's a little troublesome, maybe a big trouble, but there's got to be some silver linings.
Well, for the Amazon rainforest,
Here it
if
comes.
we can start reforesting right now, all the countries need to work together. We can help to save it, but it has to happen soon. We're very close to a tipping point. Everything else, we need to reduce the warming of the planet, Vlad. If we reduce the warming of the planet, we can slow these impacts. They'll still happen gradually, but more gradually. It will give us time to adapt.
Well, what we saw yesterday is a first step in the right direction.
Absolutely. Yeah, sure.
Jeff Berardelli, thank you very much.
All right, guys. Well, you know, the reason
I'm here
why...
for my
Oh,
11
these
o'clock appointment.
commercials. Wait a second. How do I get this done? Okay. I am so sorry. I'm going to turn down the sound effects, the system audio now. I'm going to mute it because if Scripps comes on one more time, I'm going to lose my effing mind. Okay. So that we picked Jeff Berardelli, and let me tell you, because Antonio did interview him. And Jeff at the time was in Florida. He was a Florida a weather guy, you know, in Florida. And so I guess it's like we got a little bit of a fondness for Jeff because he's been on our channel, and whether or not he knows it, I had repackaged it and all that. So anyway, let's get back to the article, and I'll take a gander at this one. And I think pretty much, though, he talked about everything, the decades of research and now lived experience. It has become clear that the impacts of climate change are having, not will have, they are having drastic and far-reaching consequences on our planet. Well, of course, everybody here knows this, of course. But, you know, this article I put it on my actual Facebook page for those people that might, and not the Arctic one, but my regular one, for those people that may just not understand or need something simplistic like this, you know, that talks about the consequences, extreme weather and sea level rise and loss of biodiversity at a pace which these unfold, and their eventual severity hinge on what happens. And like he said, the linchpins in the climate system. So I'm not going to go through all this. We can go down to 2019. Professor Timothy Lenton, a global leader on the subject, identified 9 climate tipping points, from melting permafrost in the Arctic to the loss of the tropical coral reefs. So here we will focus on what he deems the 3 most critical ones: the Amazon rainforest. Oh, for God's sakes, I'm getting rid of it. Okay, Okay, I'm going down. And the Gulf Stream. Lenton highlights these three because the West Antarctic ice sheet and the Gulf Stream system, that passed might have passed, right? The word may, could, yes, does. But CBS had spoken to him and several other scientists about the state of the tipping points. So while they have different areas of expertise, ranging from oceans to atmosphere to biosphere, their message was unanimous. Changes are happening faster than what was expected, and the chance of hitting the tipping points in the climate system it's just a decade ago appeared remote and far off. Do we all remember that? Remote and far off? I don't think any of us felt that way. We kind of knew, but it seems much more likely and immediate. So this is why Lenton is raising the alarm. In just a decade, the risk level has gone up markedly, and that should be triggering urgent action. Instead, we got a fucking asshole like Donald Trump who had put us behind the eight ball. I don't know if what's going on is much better now, but I think John Kerry, at least, he may be what he is, but John Kerry, he knows the truth. He does. He knows what's going on. He might sugarcoat it, but he knows what's going on. So Jeff talked about the Amazon, and it's huge. It's like the size of the contiguous United States. 3 million species, guys. 10% of the Earth's known biodiversity. And of course, right now, it's in the hands of another madman, and that madman is named Bolsonaro, okay, who is letting his people die over there anyway. Sorry, my editorial is, I can't help myself. So there is Dr. Lovejoy. He's one of the experts on this. He says, we are really right at a tipping point. We see the signs in longer dry seasons, hotter dry seasons, tree species that prefer drier conditions. And this was really interesting, gaining dominance over those that prefer wet conditions, explains Lovejoy. And he's a professor at George Mason University, and he's a founder of the Amazon Biodiversity Center. So we know that it's right there at the tipping point right now. It's there at the tipping point right now. And he started studying in the 1960s, guys. 1960s. He's been at this a long time. 10 million people live there. And the forest was 97% intact. 97% intact. And now there's 30 million people. Holy crap. And living there. And deforestation in Brazilian Amazon is at 20%. The critical level at which scientists believe the Amazon starts to tip towards the point of no return. I should have had the Kansas song. Point of no return. If the younger ones don't know it, Kansas was a band, and it was a good band back in the, what was it, Jennifer, the 70s?
Probably, 1978, something like that.
Yeah. So we know, and it's a good band, and we know good music. So, all right, we know good music there. That's a little sidetrack, but it says that if it starts, it's not going to survive as a lush, wet rainforest. And it's going to transition into an arid savanna. And he says that this transition from rainforest to savanna could happen as fast, and I like this, as a mortgage cycle. I would say it's a matter of something that happens on a time scale of decades, like 10, 20, 30, not centuries. So a lot of people alive today would actually get to see that negative consequence. I'm not clicking on whatever that is. Lenton, he's less sure. So there's the one guy who says it's happening, and then there's the one guy that has to put the qualification on it that he's not sure. I wish I knew how close we are to a tipping point, but he agrees that signs are pointing in that direction. And we have work submitted showing early warning signs that the whole forest is losing resilience. I'd say that for the drier southeast side of the Amazon, it is already under a serious risk of fire amplified loss. So it's only a rainforest because it's a rain-making machine. And it generates 50% of its own rainfall. Well, that phenomenon is made possible as the leaves that make up the canopy of trees exhale. They exhale moisture upward in that process called evapotranspiration. Evapotranspiration. Everybody repeat after me. Evapotranspiration.
Evapotranspiration.
Yeah, right. She got it. We got it. Okay, we know it. So it condenses in that cooler air, okay, above and forming a river of clouds that rains the moisture back down. So just by watching what happens after a rainfall in the Amazon, and afterwards you see plumes of moisture coming up out of the canopy of the forest, and that all moves westward to become rainfall once again. Explains Lovejoy. But the trees are disappearing, the forest becomes fractured, and then I'm going to go down, we know lumber, landowners grabbing land and large corporations. It's nothing none of us know, but this article is good for those people that don't know, that don't pay attention. And this is mainstream media. So this is what you're going to get. But it's not bad for mainstream media. People criticize, but what are we going to do? This is more than we've had. This is a lot more. I mean, Jeff Baradelli is giving us a lot more than anybody else has, and CBS is giving him that. He's giving him that, Jen. So
Yeah.
I'm going to just go over, because I don't want to talk about goddamn Bolsonaro, but since the 80s, NASA has observed a significant increase in something called the vapor pressure deficit. And it's over the forest. So it's the difference, or it's the gap between the amount of moisture in the air and the amount it can hold. That gap is widening, which represents a drop in relative humidity due to an increase in greenhouse warming from the human-caused climate change and aerosols from biomass burning. Well, there you go. You see the trend in vapor pressure, and you see how it goes up. NASA measures more vapor pressure deficit increasing in the Amazon basin over recent decades. It is drying up. So when the atmosphere is less humid, it has room for more moisture, and it becomes very thirsty, pulling that moisture out of the ground and making the vegetation drier. It leads to more drought and is very similar to what's happening in California, which is making the wildfires way worse. Over the past century, the temperatures in the Amazon have risen by over 2 degrees Fahrenheit. And in the past 50 years, the dry season has expanded by a month. A month! That is a lot! A month! So he says that the impacts of a transition of the Amazon rainforest to a more arid savanna would be devastating, both locally and globally. 30 million people, many of them indigenous. And of course, the indigenous people are the people getting screwed. They're the ones that are getting hurt. And they depend on that reliable rainfall. It's, produced by the rainforest. And significant loss of rain means an escalation of drought that may be devastating to agriculture. A drier Amazon would also mean significant loss in biodiversity, the extinction of unique creatures which exist only on the one region. Just makes me so sad. I'm going to go down a little bit because I really want us to cover all of the information that you have in the next article. But I'd say, everybody, it'll be in the show notes. Like, this guy says there's still hope we could stop this from happening, but the task is urgent. He says nations which make up the unique ecosystem must cooperate and immediately work to reforest the Amazon. Maybe it could happen. Maybe there it could happen, but how can it happen in this political atmosphere, Jennifer? I don't know. I really don't understand, but let's what is it? Look at look at the worst, but hope for the best.
Mm-hmm. Yeah.
Oh, there's that old hopium. And then, of course, there's the West Antarctic ice sheet. Now, he talked about this all. So I'm just going to go down a little bit more. And because Jennifer's going to cover some pretty heavy stuff. This is that we used to assume that Antarctic was stable, but no more. So in the last few years, researchers have become alarmed at several areas in Antarctic which are showing signs of instability due to a warming climate and shifting ocean atmosphere currents. So it's Pine Island and the Thwaites glaciers. I wonder if I could make this bigger. I don't think so, but you guys get the shot. You guys get the idea because I mean, there's 59 of you. Okay, 59 of you understand. This is like a review refresher course. I think so. It really is. So I'm not going to go much farther because of the fact that you have such good stuff. But here's the Pine Island and Thwaites glaciers have significant ice shelves which float on the sea. So lately, the warmer water is getting underneath, breaking up the ice shelf and eating away at the grounding line. As that happens, more of the ice floats off the sea bed and then adds to sea level rise. Since the backside of the glacier is below sea level, as the grounding line retreats, an increasingly thicker portion of ice floats, adding even more to sea level rise. And then they were talking about the study from last month found early warning indicators of the onset of that instability. So people say, well, 2100, blah, blah, blah. I don't know. So Lenton says we are indeed in the midst of or near a tipping point. And that's all I have to say. I mean, the article you can go on. I'm going to not at the moment because I want Jennifer to get started on the other articles, and I have to re-pull up Scripps because of the fact that Scripps kept playing and screwing me up. So what do you say, Jen? What do you think of that article that we just
it's amazing, and it just very much like all these ecosystems are all collapsing all at the same time. Every single one of these ecosystems are past tipping point all at the same time. And 11,000 years ago, there was a dramatic sea level rise event called Melt Pulse 1A.
Really?
That was 11,000 years ago. And it also coincides right around, I think that there was sort of a comet or something that was breaking up. In any case, this sea level rise ended up adding 15 feet per century of sea level rise.
Wow.
So, yeah. Wow. For a couple thousand years.
Wow.
Yeah, but who's counting?
Yeah, who's counting, right? Mm-hmm. I'm just pulling up scripts.
So we can look at that. Actually, they have that sea level rise chart.
Okay, do you want to go to EOS? Which article? EOS?
Yeah.
Okay, I'm going to turn.
Yeah, I was just in the tipping points one, but yeah, let's jump over to the EOS because that's what I was doing right now. I was finishing up the sea level rise part of the tipping points article.
I'm sorry
because it's pretty interesting. Oh, that's okay.
I would have put it back on, but I was playing, engineer.
That's okay.
Producer, director, engineer. All right, so let's get to this one. This is an important article.
Right.
Take it away,
really
Jennifer.
Important. Yeah, it's really important because I've been focusing on methane pretty heavily, like I would say the last 8 or 9 years, because in my mind, I always kind of like put that as, we're having tipping points breaking all over the world. But this one in particular is interesting because it's so dramatic. And everybody, it's been a point of great contention, as we know. Some people say, oh, this methane bomb theory is really just, scare tactics and fear-based things. Well, it is scary and it is fearful, but it also, I believe, is real. So now they have found methane reservoirs in the Laptev Sea area. And it's in the East Siberian Arctic Ocean. And there's been a joint Swedish, Russian, and US investigation. And it has discovered that there is an ancient gas reservoir that is responsible for a huge amount of bubbly leaks that are going on in the Laptev Sea. And they have found that it is stored in reservoirs below the sea's submarine permafrost in the form of methane hydrate. And this is solid ice like structures that trap gas inside. So it's very, very condensed when it's frozen. And as soon as it goes straight from the frozen state into the gaseous state, there's no liquid state, it expands like 167 times. And that's like a huge amount. It's like very, very small and then becomes very, very big. So that can lead to explosions. So microbial methane is released in a slow gradual process. Disintegrating hydrates in reservoirs can lead to sudden eruptive releases. So this is what we have right below the seabed in the Laptev Sea. So the thing is, it's fine as long as it doesn't get hot. However, things are getting hotter. And now there's an even stronger greenhouse effect. If methane releases, there's even a stronger greenhouse effect than carbon dioxide for a short period of time. And that can substantially amplify global warming. To anticipate how these methane releases will develop over the coming decades, we need to understand what reservoirs of methane the releases are coming from. And that's from Örjan Gustafsson, the leader of the research group. And he's at the University of Stockholm. So it's right there, this area, like Sandy, do you see the map? The map where it shows where this is. It's nestled right in the middle of the Laptev Sea.
I've got
and
it.
there are two blowout regions in particular, those two black dots. And those ones are the powerful ones. And that's what I would keep my eye on, number 13 and 14 in that map.
Wow. You know what, Jennifer? I think those are the scary ones. And guess what? Those earn the Environmental Coffee House flush of the day. Oh, yeah. Flush that methane down. Yep. There you go.
Yep. So this is it. This is interesting for methane nerds. The big finding that was that we really have something that's coming out from a deep pool. So we're starting to map this out. As the permafrost thaws, it opens new pathways that allow methane to pass through. They're chimneys, right? Methane chimneys. So this pool contains more methane than is currently in the atmosphere. Should I repeat that one more time? This pool contains more methane than is currently in the atmosphere, and it's thawing. This, unfortunately, is a risk that this methane release might increase. I would say will increase, not might increase, right? So it will eventually have a sizable effect on the climate. They're so understated, it's scary, right?
Yeah.
Yeah.
Absolutely. Understated.
Yeah.
Where are we?
Yeah, so they say that
myself.
there's, and this is just there can be other sources. It is quite plausible that there are other sources. The thawing permafrost or the hydrates can be the major source of methane in other parts of this enormous system. So they're still exploring it. Even though the study area concerns one of the places on Earth most difficult to research, the Arctic. they're going to conduct more expeditions to map methane sources in the East Siberian Arctic shelf. The permafrost is a closed lid over the seafloor that's keeping everything in place. And now we have holes in this lid. That means we really have to keep a close look on it. So there you go. That's the freaking, methane reservoirs of giant reservoirs of methane in the East Siberian Arctic shelf. Scary stuff.
Yeah, and what gets me, Jennifer, is that all of this is coming out now after it was saying, oh, there's nothing there, nothing to look at, move along. You're just panicking doomers. It's
That's right.
Yeah. And you were insulted in the media. You were insulted for your work. And that really sucked, and it pissed me off. It pissed me off. I will defend you and kick anybody's ass. Okay.
Here's the deal is here, hun. I don't care. Like, I wish I was wrong. I hate to be able to say, see, I told you so. It's not like fun. It's not good. But there's more, right?
Oh, boy.
I am so sorry.
Oh.
I am so sorry. So, Sandy.
Yes.
We were talking about the 70s and stuff like that.
Yes.
Did you ever have a lava lamp when you were growing up?
And in fact, they're back because I had to go to Home Depot for gardening. I had to. And they're selling lava lamps, and I thought about getting one, but I like the light bulbs that I can control the colors behind me, so I didn't get the lava lamp. But that would just be more junk I didn't need. And I don't need any more junk.
Right. Well, it's not a random thing that I'm bringing up right now, but I want to keep this lava lamp visual in our minds because we're going to talk about a new concept now. We're going to talk about heat bombs that are destroying Arctic sea ice. And these heat bombs are masses of hot, salty water breaking off from the Pacific current that's just winnowing its way right up the Bering Strait in between Alaska and Siberia. And the thing is about this water, it's throwing off these big hunks, like ginormous hunks of hot, salty water that kind of isolates unto itself, right? And it's a heat bomb. And basically it's hotter, it's saltier, and it's diving under the ice, and it's hotter than the water on the surface, and it's just basically melting the ice, and it's going all over the Arctic. So here's my question is here, hun.
Yes.
What happens when these heat bombs of hot, salty water go and sit themselves on top of the permafrost in the Laptev Sea? That's my question to you.
It's not good.
No.
Well,
Good.
a heat bomb sits on top of the permafrost. What do you think is going to happen? It's hot water and it's blah, 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 blah. It's a mess.
It's all gonna melt.
It's a mess.
So this is the heat bomb. And Sandy, there is such an interesting video about, there's a couple of interesting videos about these heat bombs. This is hot off the press, guys.
Yeah, maybe I can pull one up, Jen. Maybe we could pull that one up.
I sent you the YouTube one in my notes to you.
I have it.
Heat bombs destroying Arctic sea ice. And I think that it doesn't have any words, and I can talk through this at the same time.
All right. Well, let me look for it. I'm going to put you way up on.
So anyway,
screen. There you go.
Enough preamble. Right. Let's talk about these heat bombs. So this is right out of the Scripps Institute of Oceanography. I'm sorry, I went to university in San Diego, UC San Diego, and I worked at Scripps a couple of times in the 70s. So these heat bombs are destroying the sea ice in the Arctic Ocean.
Are you kidding me?
And Jennifer, what?
I hear these videos that are insane. I hear them, but I don't know why they go on.
Because it's retarded.
It's terrible.
I'm sorry.
It's awful. It's awful.
It's awful.
We should write to CBS 8. You want to do this?
Do
some. Yeah. All right. Well, I
You
got it up
guys are
there
driving
now.
us all crazy. So there's this woman, and I came upon her video at the bottom of this article. Her name's Jennifer McKinnon, and
Yeah,
she is the lead at Scripps Institute of Oceanography, and
that's what I'm
she's
looking for.
researching the Arctic Ocean. And so this heat bomb, as I was mentioning to you, describes pockets of warm water from the Pacific Ocean that are speeding up the melting of the sea ice. So this warm, salty, dense Pacific Ocean water enters the area through the Bering Strait, and it settles deep beneath the frozen surface. So the mixing of the different waters generates and they said generates, that's the wrong word. Stimulates would be the
Okay.
right word. Stimulates phytoplankton growth in addition. So there's a big bloom of phytoplankton in addition to this heat bomb.
Mm-hmm.
And it creates this heat bomb melting the ice above because the heat bomb is below. So this previously had been unknown. So this is new.
Brand new.
So these pockets of warm water can last for months, even years. They stay isolated amongst themselves that long, causing current heat bombs. And they mix and interact with the surrounding water. So this accelerates, obviously, the sea ice melt in the Arctic, and that was predicted before. And it leads to local feedbacks between ice, ocean, and atmosphere. So this is the role that the warming ocean plays on those feedbacks. And this is all detailed in a brilliant video that features Jennifer McKinnon as she was interviewed by CBS.
And I think we should
Diego.
play it. I think it was really good.
She's
I think we
so
should play
good.
it, Jen. I have it
Can
keyed
you?
up. Yeah.
Okay.
You
Can
let
we
me
do
know.
it full screen?
Yeah,
Can we do it full screen?
yes, and
It's only 11 minutes. It's
it's
really
good, guys.
compelling.
Yeah. Tell
It's
me when you
really
would like
compelling.
me to play it.
Let me just see if there's some other things that we should say about this, but she explains it better than I ever
Well,
can.
and she's from your
Let's
hometown.
She is. I
She
went to
is.
UC San Diego
know.
for like 5 years. I loved it. It was so beautiful there. Let's go ahead and play that video, Sandy. I'm ready
I'm
for
going
it.
to try this and pull it up, and system
Oh,
audio is
perfect.
no
That looks
longer
beautiful.
muted. All right, guys, have fun. This
I am
is
a
good.
professor of oceanography at the Scripps Institution of Oceanography, University of California, San Diego.
Great. And you actually went to the Arctic to study why the ice there is melting.
I did.
Whoop, sorry.
I've been there a couple times. The most recent time was for about a month in September of 2018.
Now, can you tell me, that the title you're giving this new, I guess, not phenomena, but you've discovered what is actually making the ice melt there?
Yeah, so the feature we've been looking at has different names depending on who you ask. The heat bomb's name is sort of a colloquial, informal way of referring to these features. These are pockets of warm water that lurk subsurface in the Arctic. They're coming in from the Pacific Ocean through Bering Strait into that part of the Arctic Ocean. And as they arrive, because they are a little saltier than the surface water in the Arctic, which is fairly fresh, even though they're warmer, they can dive beneath the surface. They carry a lot of heat with them. They're able to swirl fairly far north into the Arctic, bringing a lot of heat deep into the Arctic and melting the ice from below. So these features have been seen for a little while, on and off for the last decade or so. But our contribution in the paper that comes out this week, I think, has really helped us understand how they work, how they get there, what makes them, and kind of what controls how much heat is coming into the Arctic this way and accelerating the sea ice melt.
Please tell me about, the process of getting there for your research and the type of equipment that you use there.
So getting there, getting to the Arctic is still no easy task. So we take a series of flights to get to Nome, Alaska, which is a small town on the west coast of Alaska. It's where the Iditarod ends, and the home of the story about Balto the dog, which is a children, is popular as a children's book and very popular locally as a hero story. We typically take a ship, which is the research vessel Sekuliak, run by the University of Alaska, and it takes about 3 days on the ship to get all the way into the Arctic. So it's quite an ordeal to get there, and then we stay for about a month. If you're going all that way, you might as well stay for a while, living on the ship, working on the ship. We work 24/7, round the clock, day in and day out, weekdays, weekends, all the time. It's hard work. These aren't, luxury cruise ships. They're working science ships, but so it's a phenomenal opportunity to be there, and one I feel incredibly privileged to be able to be in places like that and do this sort of research. So you asked about tools.
Yeah, one of the things that I noticed in the video is a metal capsule of some sort that you put beneath the water.
Yeah, so we build many of our tools here in our lab at Scripps. So we have a dedicated team of amazing engineering talent that builds a lot of these instruments from scratch. And we have found that if you want to see the world around us, and particularly the ocean, in new ways and see things that people haven't seen before and get insights into how the world around us works, you often need new tools to be able to see the world in different ways. And so the tools that our group makes allow us to see subsurface in the ocean with greater resolution and detail than most previous measurements have allowed. And a lot of the processes that are mediating how this heat comes in are really intricate and complicated. And if you don't see them clearly, you can't understand them. And so our tools allow us to very rapidly sample from a ship. So we have a fast winch that allows this instrument that measures temperature, salinity, some biological properties of the ocean to go up and down really rapidly as we move the ship around. And so we can identify features, these subsurface heat pockets, and see them in really great detail.
If you could explain in a little more detail what you're describing as a heat bomb and how this works.
So the Arctic, like most oceans, has different layers in it. So the surface water is really cold and fresh. It's where the sea ice lives. So if you look at the ocean from a satellite, you see the surface as near freezing temperature almost everywhere in the Arctic, much of the year. But this water coming in from the Pacific, it is warmer and saltier. And as this current comes in, it comes in through Bering Strait. It flows through this very constrained channel called Barrow Canyon, which is on the northwestern tip of Alaska. And as that current meanders around, it spits off these little blobs, these little heat bombs, which pinch off from this meandering river of warm water. And they pinch off and they dive beneath the surface, and they sort of ooze out into the central Arctic. And that process of how you get these boluses of heat pinching off from a current is the part that we were really excited to study and understand. And that helps us understand and predict how much heat is entering through this type of mechanism.
How serious is the possibility, of us losing all the ice there in the Arctic?
So it seems quite likely that all of the ice in the summer will be gone in the not too distant future in the next decade or two. There will still be ice in the winter, but the year-round ice won't be there. And so that is significant for a number of reasons and quite disturbing. One is that if you just have seasonal ice, so it freezes in the winter and melts in the summer, it doesn't get very thick. The ice that lasts for multiple years tends to be much thicker. It plays a different role in the climate. It provides a different type of environment for the ecology of the Arctic, the polar bears, the walruses, et cetera. So losing the year-round ice has huge implications for the ecology, for the indigenous communities living around the Arctic, for the global climate, for all sorts of operations, commercial operations in the Arctic, naval operations in the Arctic. There's very wide-ranging implications, which are pretty dramatic.
I mean, that even affects our weather here in San Diego, right?
Oh, for sure. Yeah, and so there's a number of ways that it does. One is just that the whole climate is interconnected, and the the Arctic Ocean is a bit of a canary in the coal mine, and it's changing in ways that not only preview how the rest of the world changes, but it influences other weather. One of the ways that's been in the news recently is that it seems as though when you change the temperature difference between kind of the warmer temperatures we have in the lower 48 and the colder temperatures of the Arctic, as the Arctic Ocean warms and the atmosphere above it warms, as that temperature difference changes, you start to get more meandering of the jet stream, and you get these Arctic vortexes coming down, which have been dramatic features in US weather recently. And so it's all connected. It seems very far away, but from those weather pattern perspectives, it's not really.
As somebody who lived and worked in that area for a while, can you describe to us here in San Diego? I mean, I myself, we don't have the appreciation for actually seeing polar bears and sea life there. Can you tell me about some of your observations there?
Yeah, I mean, it's amazing. It is such a privilege to be able to work in such a pristine and beautiful place. We try to not get too close to those animals, to be respectful of them and their environment, but we see them in the distance, and there are walruses and polar bears, and there's whales, and really a unique ecosystem from kind of the microbial level on up. It's a totally unique and in some ways otherworldly place. It feels very far removed in some ways from regular life, in a busy city like this, to be in it's very quiet, it's very cold, it's really beautiful. The northern lights come out at night. It's amazing. But we're also very aware while we're there that the things we're studying and the way that it's changing are very dramatic, not only for the Arctic, but are so interconnected that it's not actually as far away as it seems.
Yeah, kind of tragic that these animals are going to be hurt in the long run by the loss of this ice.
Yeah, I mean, the animals their whole world will change. We're also trying to be very respectful of the native communities and indigenous communities that line all the way around the Arctic, because their way of life is based in some part on those ecosystems, and is going to be dramatically changing as well.
So now with the new knowledge that you've gained from your research there of these, so-called heat bombs, what next? What happens now?
Well, now that we feel like we as a community, I mean, science is an incredibly collaborative enterprise, which is one of the reasons I really like it. So there's a wonderful group of people from nations all over the world working on these issues, and just our group involved collaborators from the US and the United Kingdom and Germany. We work closely with colleagues in Canada. Anyway, the whole scientific community is trying to think about what we do with this knowledge. And the first obvious step is just to improve our forecast models, improve our forecasts of what's likely to happen. That if we have a better prediction for how the Arctic is changing, how the global climate will change in response, we can prepare, we can adapt, we can adjust, we can at least know what's coming our way.
Pretty phenomenal. Anything else that you want to leave our viewers with about your research and what you learned?
No, I guess, I talk to my kids' classes sometimes, and I think people often have this view of science that it's sort of stodgy, or it's, people are working on problems in a certain way, and it's so exciting to do this type of work. We don't know what we're going to see. We discover things like this. You figure them out as you go along. It's creative, it's exploratory, it's a community collaborative effort. It's a wonderful thing to do that I feel very privileged to do, and I would certainly encourage lots of people to get involved in science any way they can.
Thank you so much for talking with us. Appreciate it.
Yeah, of course.
That was awesome. And I'm going to put us back on. Yeah, that was great, wasn't it? She did a good job. Jennifer, I can't hear you. I got it. I fixed it. I muted it. Okay, so I think we covered a lot here, and maybe we'll just have a little discussion, and I have some comments that people made. What do you think, Jen?
Absolutely. Let's talk
All right,
about it.
Let me see. My favorite comments, I put somebody um, John, so are the water streams beginning to undulate similar to the jet streams with changing temperature gradients?
Mhm. Yeah, well, that's right. The jet stream is getting a lot droopier um, as the temperature gradient between the temperate zones and the Arctic decreases, right? So that delta is decreasing and it's just dripping like an ice cream cone. And at the same time, the Pacific Ocean is just getting a lot hotter. And there's always been a push from the Pacific Ocean into the Arctic, and it's going through the Bering Strait and that narrow canyon called Barrow Canyon. So
Mm-hmm.
it's pretty creepy. You can just picture it, this lava lamp basically of hot, dense, salty water, coming in and lurking under the sea ice and swirling around. And it's melting everything. And there are a lot of things that are assaulting the ice, and as she said, and she's just like the art of understatement, right? I mean, she's such an consummate scientist, but she very much realizes how serious this is and how
Oh,
this is going to change things. This
I would
isn't
say
just like, oh,
so.
great for shipping in the Arctic
Yeah.
Ocean, yay commerce.
Yeah.
This is a serious situation. It's going to
She's,
change the climate. It's going to change the jet stream even more.
yeah.
Um,
She's no sellout.
when there's no more sea ice, there's not going to be any more buffer. The air conditioner of the world is going to be broken. These heat blobs are attacking the remaining sea ice, and they're giant methane reservoirs. Other than that, we don't have any problems.
No. Well, Hunter's got a comment. Environmental Coffee House, Jennifer. Sinkholes are increasing everywhere. Example, Turkey. Can you refer to that? Can you refer them to methane release, or is it just soil erosion in other places?
Well, I can't really speak to Turkey, unfortunately, Hunter. I don't know specifically about Turkey, but I do know this. Those methane blowholes, craters that you're talking about, primarily found or noticed in the Yamal Peninsula, but they're pervasive. And it's in this terrestrial permafrost that's methane rich and that is basically thawing. So you remember last summer, there was over 100-degree days up in Siberia for a really long time. One of the effects that we didn't talk about yet is that when they had these big heat waves in Siberia, when that
They're
land
all,
got hot,
yeah,
the pingos really activated and a lot
yeah.
more blowholes happened.
Mm.
So I can't really speak to sinkholes in general because that's probably a different principle, and it's probably, as you say, the land eroding and different things happening, and it could be per the geographic area. But up in that permafrost area in the Yamal Peninsula and all throughout Siberia and even somewhat in Canada, these heat waves are having a direct and dramatic effect in the blowholes going
Wow.
off.
Wow.
Yeah.
And then
Yeah.
let's see. Jim, at what time and Tanya, are you with him tonight? I hope. At what time does the heat bomb become a heat current constantly flowing north? Hmm.
Good
Good
question,
question.
Jim. My
Research.
understanding is that there is a heat current that's squeezing itself through the Bering Strait, kind of like, when you squeeze toothpaste out of a tube. I mean, it's basically it's a whole different type of water because the Arctic is fairly fresh and the surface of the Arctic Sea is very fresh
Mm-hmm.
and very cold, and these hot heat bombs come in as a current, and there is a current that goes through that's coming from the Bering Strait. And also little eddies break off of these currents, and they're just kind of
Wow.
rogue and they go all over the place, and those are the heat bombs. I think this is so fascinating.
Mm. It is fascinating, and we've got everybody out there discussing it. but we are
Yeah.
on the hour mark. So I was
Indeed.
wondering, Jennifer, if you would like to do the wrap up for the show.
Well, I think the this is I say this a lot, but this is a profound time to be alive. This is a time of deep transformation. This is a time of demise and extinction. And it's also a time to be awake, which all of us who, participate in this group process really of educating ourselves do. And we are at a time of tipping points. And then there are all these new processes that are just now being understood. And yes, these processes might have been in place for a long time, but we are starting to understand them. We are starting to understand the impact of watching our sea ice go at the top of our world as it's going. And it's kind of like, what a time to be alive. It's pretty crazy. Right, Sandy?
She said 1 year, people. The scientist said 1 year for the ice. I'd like to see her do a video with Paul Beckwith. I think that would be a great one. I'm gonna send him. I'm gonna see if he wants to contact her. But I like this show. I learned by listening to you, and I hope everybody out there has enjoyed the show. And this hour went so fast. Wow. And I'm really happy Jennifer joined me. Just a little housekeeping here. Summertime comes. We might go on a little summer schedule. I'm not sure yet how Sundays will work, but Wednesday isn't bad, Jen. We'll see. We're gonna take it. I have to, I have a lot of responsibility, and I'm gardening up my whole entire property, and that takes a lot out of me, and it takes a lot of time. But it's also everybody's been sending their videos, their garden videos. I have a lot of stuff I'm compiling in the folder, so by the end of May we should have a really nice first piece in the trilogy of everybody's stuff. So don't forget, environmentalcoffeehouse@gmail.com. I didn't put it in here, but please don't forget to send us your beautiful stuff. People, they've been just sending me such beautiful things from all over the world. I can't wait to make this.
It's going to be so cool.
Yeah, I think so.
Celebrating life in the midst of demise. How's that, Sandy?
Say that again.
Celebrating life in the midst of demise.
Yes, absolutely. That was beautiful. That was absolutely beautiful. So I think what I'm going to do as we say goodbye is play a little bit of our quiet little music that we end, our little and thank you all for being with us. It's been a good show. And Jennifer, thank you for being here with me on a Wednesday night, because I know it's not easy for you. I know.
My pleasure.
Thank you. Everybody, thank you so much. Thank you. And you all have a wonderful evening. And I have a guest on Friday, Christine Mattis. You should enjoy this. And she's pretty cool. She writes for Counterpunch, and she's quite a doomer. So this should be interesting. And then don't forget, Sunday is Overshoot night. It's the night we have Michael Dowd with us. So everybody, don't forget to listen to SoundCloud to Michael Dowd reading William Catton's Overshoot, please, because he's live with us Sunday night, and we are going to go over all of the stuff that is in Overshoot and what William Catton talked about, and we'll get into some deep stuff. So don't forget that Sunday and Friday we'll be here. Okay, Jen, you can give the last word.
Peace out, guys. Been a pleasure.
Peace out. We love you. And don't forget, if you want, guys, you can become a member. So I'll do my little shtick here with the Buy Me a Coffee. Become a member. I'm trying to do something with that. All right. Love you guys, and see you on Friday.